going to talk about ANOVA test. ANOVA stands for Analysis of Variance, and then we use ANOVA test when we have more than two independent variable groups. And we have several different types of ANOVAs. I'm not going to spend a lot of time talking about ANOVAs and a couple other ANOVA type tests. I'll give you an example of a simple ANOVA so you can see how those work, because you'll probably see some of those in your research papers. I wanted to expose you to the terminology that's out there when you're reading research papers, so you kind of have an idea what they're talking about. So let me go over these three and a couple more, then I'll give you an example of an ANOVA test. The simple ANOVA, it's also called a one-way ANOVA. One-way ANOVA. Again, this is for two or more independent variable groups. Then we have a factorial ANOVA. And what a factorial ANOVA is when you have two or more independent variable groups, and each independent variable has a factor. And what I mean by that is, let's say that we have three independent variables. We have and each independent variable we have a different level. Let's say we have a independent variable of intensity, we have an independent variable of fitness, and we have an independent variable of age. Then for each one of those independent variables we have a level or a factor within it. For example, for intensity we have high intensity, medium intensity, and low intensity. For fitness level we have high fitness, medium fitness, and low fitness. Then for the age factor we have let's say 20 to 30 years old. Then another factor would be 30 to 40 years old, and the last factor would be 40 to 50 years old. So we have three independent variables, and for each independent variable we have three different factors or three different levels. That's a lot of things going on there. And so that's a factorial ANOVA test. And you see there we have, it can be written as a 2x2 ANOVA, or like I just did was a 3x3 ANOVA. You can have a 2x3, we can have a 2x4, 2x6. We're not really limited on that, so you'll see some of that language used in research papers. Then there's another ANOVA called a repeated measures ANOVA, and it's like what we just did with the triglycerides and the weight test, but we have multiple independent variables here. We pre-test them, we post-test them, and we run another calculation to determine the significant differences between the groups. Another type of analysis of variance is called analysis of covariance, which is ANCOVA. Oh, I misspelled again. They're supposed to be ANCOVA. I thought I checked all this before I put this up here. ANCOVA on the title, that's how it's supposed to be. ANCOVA, sorry about that. And with ANCOVA, we combine correlation or regression analysis with an ANOVA statistical test. And what this does, it removes the influence of a distractor variable, which is called a covariant. Distractor variable is something that you're trying to remove the influence or the effect of a particular variable. You identify a variable that's going to cause some kind of effect on your dependent variable, so you can actually mathematically remove that influence on that particular variable. Some other ANOVAs that you should be aware of. You can have two or more dependent variables and two or more independent variables. So we can have multiple dependent variables and we can have multiple independent variables in our study. And there's particular statistical tests that we can run to calculate this, to see if there's differences between the dependent variables and independent variables. One type is called a ANOVA, which is a multivariate analysis of variance, which some of you have had articles with that in there, and you weren't too sure what that meant. And basically that's, again, you have multiple dependent and independent variables. And here you can have repeated measures again. You have pre-test, post-test on the multiple dependent variables. Then another one is ANCOVA. It's a multivariate analysis of covariance. So you have multiple variables again, and your multiple variables that you're trying to control. You're trying to get rid of the influence on a particular variable or variables, more than one, that you're trying to control. Again, this is probably getting kind of crazy and getting kind of hard to understand. Again, I think the book does a really good explaining these tests. Again, I've taken a lot of statistical classes, and I think this textbook does a very good job of explaining these different tests. Kind of gives you good examples to follow. You have to read it slow, and you have to read it a few times for you so you understand these different tests. I want to give you an example of a simple, again, another term for simple ANOVA is called a one-way ANOVA. This is from a former grad student. It's a pretty interesting study. So the research question was, will 8th grade students' cardiovascular endurance increase by using the Dance Dance Revolution video game in a physical education class setting as measured by the state-mandated time mile fitness test? Okay, so we got DDR, physical education, in a class. He used two different classes to compare it to two different groups. Our null hypothesis is that there will be no significant differences in 8th grade students' cardiorespiratory or cardiovascular endurance using the Dance Dance Revolution video game in a physical education class setting as measured by the state-mandated timed mile physical education test results. So we did a pre-test, post-test with this. So what the students did, the design of the study was that he took two different classes. He had one class where all the groups, he had a class and a control group. The one class, let me go with pre-test. Pre-testing, the class, the experimental group, and the control group all ran a 1,600 meter timed mile test and they got the results. Then the experimental group did Dance Dance Revolution as in their PE class for 4 weeks. The control group, all they did was their normal PE class, whatever they would do in there. After the 4 weeks, he had them go run another timed mile, 1,600 meter timed mile, and he calculated the results, and this is the results he found. Now the difference between this, we probably could have ran an independent t-test, or excuse me, a dependent t-test on this. We ran a ANOVA because you can, ANOVA and the t-tests are very similar. So what we have here is we have descriptive statistics up here. We have pre-test mile time in second, post-test mile time in seconds. We had 38 subjects. The range, the minimum values, the maximum values, then the mean. So the pre-test score was 852.6842 seconds, and post-test was 788. I'll just say it there, 788 seconds. So it went down. So there was some kind of change there. We don't know if it's a significant change or not, but there was a change in the time in the two tests. Then we have descriptives again. We have the number 1 equals class, number 2 equals control, and then we had the means time differences between here. We had the mean difference between the class was 94 seconds, and the control group was 113 seconds. So the class had, the experimental group did better than the control group. We can do that just by looking at the mean scores. But we have to run a statistical test to determine if that is correct. Now, the ANOVA table down there does a whole bunch of math there that you can read about in the book, but the critical value there is that F value. And F value is 0.419. And if you want to know how you get that, you divide the mean squares, the top number, divided by the mean squares, the bottom number. Okay, so a 0.419 is the F value. That's the statistic that we're looking for with ANOVA. And again, we're looking at the significance, which is the alpha level. And we know that the alpha level needs to be below a 0.05. This is greater than a 0.05, so we'll see what that means in a second. So the results. Tables 3, 2, and 3. 2 is the descriptive statistics, and table 3 was the ANOVA statistics. Reveal that there was no significant difference, and there's the F statistics telling us that there was no difference between these two groups. And the mean difference values for experimental group, and provides the data there, versus the control group. Though there was a difference of 19.07 seconds in the mean time differences between the two groups, this study did not provide support that these 8th grade students' cardiovascular endurance was improved by using DDR as measured by the state-mandated timed mile physical fitness test results. So in the long run, he did not find that DDR increased cardiorespiratory fitness. He, in his chapter 5, discussed, he had quite a few limitations. And one of the limitations that he had with this study is that DDR, you can't go for 20 minutes on DDR. If DDR was able to change it where you can run it on continuous mode, maybe the kids would have improved their cardiorespiratory fitness. But the way that it was set up, he was not able to show this as a result. Again, ANOVA tests are used for studies when you have more than 2 or more independent variables. Those are ANOVAs. We can also do studies where we have multiple levels of dependent variables and independent variables. In the textbook, the last page of chapter 9, it has a table 9.4 where it provides a different comparison of the different statistical techniques that you can use depending on the types of independent variables and dependent variables that you have. It's a nice little chart that you have. So I hope I've provided you just a brief overview of some statistical tests to tell the differences between groups. T-tests are for just 2 groups, and ANOVAs are again for 2 or more groups.